don't know in future what happens. So we are
Yeah.
going very.
Recording in progress.
Yes, sir. So now let's get into the class. Like we have in the last class, we have discussed about the VLLM and serving, deploying the models into the cluster, EKS cluster, and then we have seen that how it will be worked. Now, similar way, we can understand today with KServe. KServe, last time we tried, but there's some errors came, and we can go with the Triton. Okay, and Ray plus Kuberay framework and Kubernetes serving system. So Ray, Ray and Kuberay, we can combinationally use it. It's a Python library for your by AML, ML based workloads, and Kuberay is for you serving at the Kubernetes side. So right now, I'm going to show two labs on this, and this one under still in the testing, sir. So I have not committed all the codes as of now because the last lab was having some troubles with the Kuberay and Ray. So I didn't went and refactor the code, but I have did the refactoring on this both of this. So what is KServe and Triton? Basically, whenever I talk about this deployment platform, so this is we are completely talking on the CD part and serving part plus serving. So serving in the sense, this is one student today he asked me like pinpointingly he asked me. So these libraries used to serve the traditional ML models and Hugging Face models, LLMs. There's traditional models also and LLM models also. Kubernetes will also support you for your LLM models, but Ray is only for your traditional ML models. So deployment and serving. So they got a questions from their interviews, I guess. So that's why he's continuously asked by calling to me. So I don't understand what is serving, how these things will be deployed. So they are asking me to deploy their models into the cluster. So I don't know how to do it. What happening, I don't know. How to create the cluster site. So this is a correct point actually. So I also told him that if you have is in a different country, so I'll be going to send the same video to him. The thing is, I already explained over the call to him that how these things and what he has to do. There are different things. It based on all the way your models and your data science engineers are working. So your data science engineers are working on the ML traditional models or log language models. So when they are going to deploy, they're given a decision to him that, hey, take a call and deploy this model. And my student is not having that knowledge, to be honest. And the people who are there also, they're giving tasks to him. They said, do a POC, create a sandbox and deploy it and prove to us which one will be the good. So he come up and he did lot of investigation on the chat GPT. He did lot of investigation on Anthropic and Google articles where he read about Triton, he read about SGLM, he read about this Kubernetes, VLLM, KServe, Triton, PyTorch, TensorRT like this. So he was get confused that so PyTorch these are models. Tensor is a model. Like this he's asking questions. So does it a Tensor is a model? Tensor is not a model. The PyTorch is a model. No, PyTorch is not a model. Or VLLM is a model. No, VLLM is not a model. What are the models, sir? LLMs are the model. Which one? Already pre-trained models like we have Mistral and all. So other models like we have XGBoost, right? So XGBoost, Scikit-learn. These are all the other ML models, traditional models. Those models we will deploy. Okay. Now, but then what is the role of these things, sir? What is the role of this case of Triton? We're talking all this, where this is going to be deployed and how those exposures serving will be happen.
Yeah, Rajani, sorry, just one thing about, you told XG Boost and all, they're modeling. I think they are all algorithms, isn't it?
Yeah, algorithms only. We eventually
Yeah.
call it the models only also. Okay.
Okay.
So
Okay.
algorithm, it's a recipe and you're giving some data, you're feeding some data to it, right? And then you're converting
Yeah.
into a model. So you call it
The model.
ultimately
Yeah.
the
Yeah.
model
Okay.
only. Okay.
Okay. Okay. Yeah.
Now I have a model right now. Let's say I have a model. So this model, I know that from our past classes, we learned it will be collecting data and training is done, evaluation is done, and also we are doing means all this is getting done in the experiment only, and then you are deploying it, right? So before you're deploying it, what you're doing, we are actually sending this to the in some registry, like it can be anything S3 from your ML flow. You are moving into the GCS or S3 or blob into your clouds. So this is where your different types will come, like that would be a .pt or .pickle or .onn, whatever your model is type is, the artifact type is the dot types. Those you will be uploaded here, and that will be you have a URL. Okay, you will be having model URL, URI I can say. Okay, this URI you will be having your Kubernetes manifest or Helm charts. Okay, both any can be or customize. You have a Helm charts this in this deployment file, in the deployment file .yml, there is a image section, right? Image section. In this image section, sorry, so this file will be there, right? So this file, you actually load this URL. You will load this URL into this file, into the pod, into this pod, into this pod. This is a pod, sir. This is a pod. Understand? This is a pod. This pod is created by what? Okay, my model dot pickle, I'll say. Okay, my model is coming and loading here, but this pod is container, right? Here there's a container is running. So what is this container? This container can be your Tensor. This container can be your Triton or KServe, like this. So these are the servers which they will serve. They'll create an HTTP endpoint, like endpoint they'll create for you. Endpoint, that means they expose with 8080, 8025, like this with port numbers inside the pod. Inside the pod. On top of this pod, on top of this pod, we have our Kubernetes service, which is load balancer or a node port, whatever. Cluster IP ultimately. Okay, we will use cluster IP only, internal. And here we will have Istio, Istio, which is service mesh for routing. So from this, you will be having DNS. So this is how your request will come. So what are my things here? Here I'm deploying is Tensor, Triton, KSR or VLLM. VLLM. So my VLLM and KServe Triton are this. So this is a stack we are creating here. Inside that you are loading. This could be a model, your traditional model, or a LLM model. You are deploying here. You're loading them into here. So with your tensor weights and all, you're loading these things here. So when I go with LLM, like me or Freestyle or those things, this pod is running in a node, right, sir? In a node. In a node. That node should be a GPU node. GPU node. When this GPU node, you have to install NVIDIA device plugin. NVIDIA device plugin. You have to install. Okay. Otherwise, your Triton will not work. Triton is for from the NVIDIA only. So they did this thing. Now, what about this PyTorch? PyTorch is something when you have a ML model. Uh, while this explanation is going on, let me create a Kubernetes cluster, sir. Otherwise, it will be taking a lot of time for us. Let me open. Uh, let me open the terminal. So you can run this. It is just a setup to run your cluster. So I would like to create a cluster, sir. To create a cluster, here under the scripts, I have create cluster. So I'll run this one. Prerequisites you can run. So it will just going to install your kubectl, these things, and your EKSCTL and all. Right now I don't have any cluster right here. I don't have any cluster in the Asia Pacific Mumbai, and I don't have any S3 buckets here because we are going to save the artifacts for our models to deploy into the pod, into the serving servers from the buckets only. Okay. So I would like to create this cluster. So we'll use KServe to deploy VLLM. Sir, again, yeah, you can include the both hybrid model, VLLM and the KServe also. So KServe is just for serving the things, and VLLM is to also for serving and inference the things inside your pod. So let me go to here.
KServe is more like the orchestration tool, isn't it?
Yeah, it's
We'll
a
use that as.
Kubernetes. Yeah, Kubernetes thing only.
Yeah.
Wait. Just wanted to run it so that it will create my cluster. So we can discuss. Now it is creating the cluster in my. It will going to eventually create this cluster. So meanwhile, let's discuss now. Right now, where am I? Here I am deploying this node. Okay. This node in your AWS cloud to be G4 nodes. Otherwise, you can go for other A1, H100, A100, those nodes. That is also fine. If you are going with your standalone Kubernetes, you can join them into the cluster and you can deploy your models and you can serve over there. Inside the AKS or inside the EKS or inside the GKE, you have to go for GPU nodes when you have your own LLMs because GPU is mandatory over there. Here my pods are going to run. Here my pods are going to run. So this pod and let's say 3 pods are going to run. Let me remove this. And this is a node. Let's say this is a node. Okay. So inside my node, if I wanted to deploy KServe, I already have a Kubernetes. Why should I go for KServe or KF serving? What it is? Yes, sir. This is my cluster. Inside my cluster, I have nodes, 2 nodes. This is my cluster. Inside my cluster, I have 2 nodes. On top of this, I'm going to run the pods. On top of this, I'm going to run the pods. So two things. Your KF serve is having KTest native and KTest raw deployment. What does it mean? KTest native and KTest raw deployment. Yeah, I know that I can deploy it from Helm chart like my workloads, or I can deploy it from the manifest files by running the kubectl command. So in both ways, I can deploy my workloads into the cluster, into this parts only, right? Now, when I go with native, okay, KF native and KF raw deployment. So when I go with KF native, the KF will be running here, KF will be running here, KF will be running here, and my user will be sitting on top. My user is sitting will be in the top. And this user, when is requested from the DNS, okay, it is coming to my STO or any routing ingress. Okay, then after it will come to my service after routing, come to my service, and then after it has to reach here to hit my pods, right? My pods will be inside. My pod will be inside. My pod will be inside. Okay, my pod will be inside. This is my pod. So how many pods in your KF will be going to run? So this is my KF. Okay. When a user is requesting, when a request comes, I'm talking about the this one. When a user request is come, that time only, when the user request come, that time only my KF native will create the pod. It will cold start. It will do a cold start and it will create the pod. Then it will serve when the request comes only. So cost effective. It's a cost effective. Like when the demand is there only, that time only it will create the pod. That time only it will consume. That time only it will do auto scaling, HPA, everything when the request comes. But the problem is latency. See, user is expecting this, and when the request comes only, you are setting up the infra, you are setting up the things for him, and these things are get ready. Then only you are serving it. That means you can experience latency. That's the problem. How speed your native systems is. Kubernetes native systems is. Okay. KF native system is. So this is a disadvantage and advantage. Both things. Raw deployment is like our regular deployment. That means I'm deploying the pod, I'm maintaining like replica 2. So whenever the request come, at least my desired pods, at least my minimum pods will be serving this request to him. So whenever the demand is more, then an auto scale will happen. Two types of things. Two types of things. So this is a disadvantage and this is an advantage. So here also one advantage there and here also one advantage there. Here also disadvantage there. Here also disadvantage is there. So it's up to our call that if it is internally in your system, you wanted to only maintain it for dev1 UAT testing systems, you can go with KF native. If you want it for go for the production systems, then raw deployment has to done. So it is, I will never recommend the go with native. It will create a lot of latency. If it's something is not happening properly, it will create a chaos over there and pods will get into the crash. But your raw deployment, always you can edit, always you can do some troubleshooting, debugging, and you can fix it up immediately. So that is the thing with your this one. So whenever you create the CRDs, so there is a inside the pod, this KF server, the server will be going to create it, right? So your KF will be supporting for your all Hugging Face, okay, your machine learning traditional models. So different models we have, right? So all of them it will support. It's not like only one thing it will support like a tensor. So what happens with the PyTorch? When you are training your model, on PyTorch, so PyTorch is not a serving thing. PyTorch is never going to serve it. It's for your training purpose or build purpose. You will develop, you'll build your train your machine learning model on a PyTorch, and then you want to serve it. Okay, so here it is going to .pt. Your model extension is going to be .pt, like this. Then you have to serve it, right? This you cannot directly deploy into the pod. How you'll convert into Docker image, or you're running into the pod? Then who will? How Kubernetes know that? Kubernetes doesn't know about pt .ppt. Don't know. How you will make it serve? Where you will going to run it? Example, you have a jar file, var file. You wanted to directly run in a server. Will you able to run it? No. We need to install Java JDK. On top of that JDK, if I say java jar dot this jar file, then JDK will understand that, oh, this is my jar. Then this will tell to the kernel, and kernel will run the service in operating system. But if I directly land this .pbt into my Linux server and say that run it, it never understand. My kernel doesn't know about it. So similar way, like you have a Tomcat, you have a uh, like web serving tools, right? Web serving, I'm telling. Those tools like Tomcat tool, or this Glassfish, some other tools are there. So what they are doing means they are understanding the packages, and then they are making an ability to serve them into the internet, into the request side, HTTP request side. Similar way, we have this KF, TensorRT and all. So for your PyTorch, how your Tomcat will only work for your Java based packages, your Tensor will also only work for PyTorch things, not for other things. Not for other things. Only Tensor will only work for your PyTorch. So that is a disadvantage. That's why we go with this other options, Triton, uh, KF and VLLM. This any type, it will able to load them. And what happens when you go for a Triton, whatever your this model package, this is a pytorch.onn, okay, .onn, or maybe it is .pickle. So whatever this package, it will going to understand this runtime and it will load. Understand this runtime and it will load. So that is the beauty of this Triton and KServe things here. That's why we will wanted to deploy this infra in a Kubernetes, and we will serve the model. Serving for what? This thing. This is the serving thing. We deploy it. It makes the serve on a particular port number, 80882580, something like that. Okay. So whenever your NLP models are deploying like this, you will be having some port numbers to them, and then you will port forward to your services, to the services. Okay. Here it will run inside that 8080. Example, I can consider my web application. Web application, a normal Java application. My Java application in a Docker file, I will say 8080. 8080 I will say. When I say 8080, this 8080 will work inside this. This is a container port number. And then I will map this with the my service. Similar way here also. You are doing something in it, and then you are mapping with your service, and the request will go like this. So you're using Istio for routing, routing the request, routing the request. Istio, you can use it. Sorry, Istio here. So let me see whether this is created or not. I did one POC where I put the model path in a KServe YAML file, and KServe created its own prediction ASP, and it was able to send a JSON from a postman to test the model, which was then served the using KServe question. How we can put VLLM? How was then served using KServe? Okay, and then and how we can put? Okay, so you're asking like in a VLLM architecture, how we gonna put it that one also, right, sir?
Yeah, so Rajni, I'm asking like this was the POC that I did. Okay,
Hmm.
my
Hmm.
model like ML flow using I did experiment,
Hmm.
and my model was in artifact, means
Hmm.
S3 artifact. My
Hmm.
model was there,
Hmm.
and I just provided in a case of YAML file, I
Hmm.
just provided the path of that model, that
Yeah, like this.
artifact.
Yeah.
Okay,
So this is.
yes, yes, it
Hmm.
was a sklearn, scikit-learn model.
Hmm.
And then I was able to like use a predict. This KServe itself created one predict API, and I was able to use that one.
Hmm.
Now my question is that we are learning VLLM, right?
Hmm.
And we are integrating VLLM with KServe.
Hmm.
So how this VLLM we can put there, means where this VLLM is coming, means in VLLM will move the model or will deploy the model inside the VLLM using this KServe, how it is, because VLLM itself will run in a pod, right?
Hmm. Hmm.
Itself run on a pod. KServe uh, will deploy it on the top of, for example, I have a Kubernetes cluster. Okay,
Hmm. Hmm.
will install KServe on that,
Hmm.
right?
So as.
And a VLLM will run on a pod. So
Hmm.
how we
Yeah.
are integrating? I'm little confused. Yeah.
Okay. So here we'll come to the custom, sir. So custom serving runtime. See, custom runtime. CSR. I can say what we will do. Like as per your question. Yeah, if I run VLLM, I'll just directly load my pre built model. Okay. So inside the container, inside the container, inside the container, we will say, sir, what? We will say this one args. Okay. So when I say image OpenAI, let me say image VLLM slash VLLM hyphen OpenAI latest something. So it is the official image it is going to run, sir. Okay. Inside this, inside this, we are going to mount the model. So model like we will write args. So in this args, I'll say model, model. I'll say the model is one. Some parameters we will give like DD type float 16 and max 16. So here we will be going to load the model. So when I'm going to load the model, I will be writing one more YML, one more YML. So this is a one YML, sir. So this is, I can say like your VLLM creation YML, and this is inference YML, inference YML.
Yes.
Okay. So in
KServe
your,
YML.
yes, in your,
Uh,
in this inference YML, I say kind is equal to inference, I will say. When I say inference, here I wanted to configure a spec. Inside the spec,
mm,
I'll say storage URL.
mm.
Storage URL, I will give my whatever you are saying, right, sir? Like your own model you wanted to keep, which is in a S3.
Yes,
You
yes.
can give it
Mm,
here. Then you can give a runtime as VLLM runtime.
mm.
So now your inference will be working on your own model and your VLLM will work for your inference. This is how we have to define, sir. VLLM YMLs for uh, custom model, custom ML model. There will be some surely GitHub will be there.
And to connect these two things, like two YAMLs, VLLM YAMLs and this KServe YAMLs, we'll need to use same namespace, right?
Same namespace only, sir. Same namespace you have to use, and you have to use these labels and selectors properly. Otherwise, it will throw in errors.
Uh,
Because
yeah,
here,
got it.
yeah, here I say that, sir, resources NVIDIA GPU, because I have to run the NVIDIA plugin. I will say that here, and then in my container KServe container, I will say images will be loading, and in inference, I have to match this all this uh, labels and all. So if I not match this, then it will run into the error. Your inference will
Mm,
be show you false, not true. It will show false.
mm, yeah, got it.
Yeah, so if we have any NVIDIA GPU, that's what I requested, sir. My NVIDIA GPU is not approved it. Sorry, my does it approved? Then still it is in pending. If it is there, then I can join into the Kubernetes cluster. I'll install the plugin, and then we can.
So
If in
we can take any simple model just for a demo, right? Any scikit-learn model means how to deploy.
yeah. Think
Mm,
VLLM. If you're taking CPU based thing, uh, yesterday I have done. I guess yesterday we are only done for normal serving only, right? The model we deployed and normal serving. We didn't load VLLM, I guess.
oh,
Yeah, yeah. Docker image. I tried to load, but let me see, sir. Let me see. I think
okay, fine, fine.
yesterday repository. VLLM. When I load deploy VLLM, I'm directly calling this Kubernetes GitHub URL only directly. Image I'm calling. Here I can answer you, sir. So this one is directly I'm downloading. It's not a VLLM, sir. I'm not calling VLLM. We're just directly done this one. The naming convention was different. That's why I said yesterday I confused this repository. I said the naming is VLLM, but there is no VLLM in it. It's directly I'm loading Olama into the container, and we downloaded one tiny model, and we did curl to it. That's it. But we
Yes,
really
yes.
not deployed to VLLM. So when we say that, then this image would be like VLLM slash VLLM OpenAI colon latest. That's the Docker image. This is this is the Docker image. This one we need to load. Okay. Okay, sir. Let's continue this lab and then I'll come to that also. See, cluster is created now.
Okay.
Okay. Cluster is created. If I go to my AWS account and the cluster, I can see my cluster and I can see compute, and I have two CPU workers right now. This is a one group. So this T3 medium is there. Init I'm going to run our lab. Okay. Next step is install cert manager for our KServe. So next step is install this one, cert manager for our KServe. So here I'm using Helm chart only to deploy this certificate managers for our KServe. Okay, this is shell script only. In this shell script, this is the actual command. Even you copy this command and normally paste also, it will work. So this beautification is for you can clone my repository and you can work on it. So that's why this beautification with the shell to automate. Okay. If I go into run, so next step it will clearly tell you that here it will have a condition. When condition met only, you can able to run this. Okay, let me copy and let me paste here.
Rajni, I have a question. Sorry.
Mhm.
So how you have connected to like this EKS cluster? In
Sir,
this terminal you are connected, right? So that's why you are running this on
yes,
cluster. This command you are running on cluster only, right?
yes, cluster only. So this create EKS cluster is there, right, sir? So it will create and then it will update my kube config. Yesterday we run right in last class. This command we have run manually. I shown you, right, sir? Like in last class, we have
Yes.
all the commands
Yes.
we run manually.
Uh-huh.
That's why, like all this command step by step. AKS create cluster, then update the cluster, so that kube config will be updated. Then I can run kubectl commands to directly interact with my cluster.
Okay.
Okay, yeah. Now step third is to install the Istio. Here also I'm using Helm only. It is just a one Helm command. It's going to install. Copy and paste. So when I'm going to run this Istio, Istio is actually going to help me to route the traffic between my serving models. So here we are creating the Istio namespace and then we are installing with the Helm command. One single Helm command, it will install all the workloads for me. So there is nothing to worry, write, manifest files, taking thinking about it. No, Helm is already available. Like KServe, if we install, then it will native thing. Like native thing, can everything it can be handled it. Similar way, Helm also. If you just Helm upgrade and Helm install, it will bring up everything for regarding your Istio. So Istio is control plane installed. So you can run all these commands. Come down, come down. See Istio cluster external IP, it is available already. So this is going to help me in my accessing, serving. Okay. The next step is install KServe. When I'm going to install KServe, the problem is no Helm is not properly there. That's the problem yesterday I was sent to figure out. When I was refactoring, Helms are not actually giving me a proper thing. In the last class also we have faced this one. So nothing is deploying properly. Then I went many CRDs and many GitHub repos and I try to pull out them. Then I pull out one URL for this KServe to be installed. So this is the KServe repository. It is from the KServe only, and there is a version. So this version is actually fixed the issue. This version is actually fixed the issue. I have tried multiple versions. So V 14.1 is the version which is fixed. So before and after versions are actually having a lot of troubles and inference services are not creating. So that is a problem. If I go and run this, copy, paste, it will create KServe for me. It's created a namespace and it is applying all the workloads for me, creating CRD and controller applied. See sir, there is a error. Okay, I expected. There is no endpoint available for serving KServe webhook. Okay, so it will be creating one namespace. What is a namespace? KServe demo. Let me Okay, pods are running. Send one. Let me run one after other. Let me run one more time. Now it is running. Now it is running. So that means the condition is not matched and two pods are in a pending mode only. It got failed. But now if you see, it will support these runtimes. It will support Hugging Face runtime, Light BGM, SKLN, Paddle, PMML, SKLN. Okay. So all this PyTorch, Tensor and XGBoost. All this runtime, whatever your package model it is, when you load it, it will load and it will try to serve. But it is not the case with your Tensor. That's the problem. But this KServe, it is created all the CRDs for you. You can see load node groups, caches, service, graph, storage containers, runtimes. All this it's created for you. If this is not there, and it has become very hard to run any ML model in a Kubernetes in a scalable structure, in an orchestration structure, it's a very hard. So to do this, you need to define your custom resource definition. There is no CRD. This KServe is an old traditional one having a lot of problems, and then the newly developed KServe. They renamed it KServe and did lot of changes in it. We can see still from the GitHub releases. If you go to the old releases, many issues are there. If I go to KServe GitHub, so if you wanted to know how any repository or any tool is working, you can go to this repository and there will be issues. These many issues are there. We can clearly understand that what's going with this tool, what's the problem at current releases. So the owner of this repository will be seeing this and is seeing the issues, and lot of people will be discussed here, and then he will approve. Then your change will be going to be merged into the main code, so then it will be released. If you see it here, KServe, the release is 17, the latest release 3 weeks ago. 3 weeks ago, so we are using 14. More 49 releases are there before. You can see there are some chat packages. None of the chat packages not working properly for me. I see some trouble, and then I like given a direct URL of that version. It worked for me, and now also you see that it worked. Right now this got deployed. You can see Certificate Manager deployed, Istio deployed, and KServe also deployed. Now next is my model deploying. When I'm going to deploy my model, here you can see manifest. In this manifest, I have sklearn iris, sklearn iris, and XGBoost iris. Same model only, but in the regression, in linear, and one is in a classification. So both I have this sklearn and XGBoost. If you open this YAML, so this is what just before Abhishek sir also talking. This is my inference service. Kind is inference service. This is a this SK learn iris model server. It's going to create like a server inside your container. So you are running a one sidecar container also to load those. Now this is my storage path, pre-trained model. This storage path in your real time, it is from your ML flow will be registered a model, and that will send those things to your S3 or a GCS or a blob storage. From there you will load them. This is a URL. This URL where I got, sir, right now, this is a Google public repository right now. Iris models are already pre-trained. For us, for this lab, I no need to train it. If you wanted to do CA also, like training purpose also, you can take your own model, any algorithm, train it, and then upload it those models into your registry. From there, you can load it here directly. This is how we can do. This is where my storage URI and the URL you will be giving, you directly load it here, and it is going to run as a server. It is going to run as a server. My iris is already pre-trained on 150 flowers, like this iris things, right? The color, leaf, it will tell you based on the whatever the inputs you will give, it will going to tell you that, oh, this is a this flower, this is a this flower, like this. So it's going to do a classification in a numeric manner, and it's going to do one more thing is called XGBoost. Same model only but different. Two models are there. Now what I can do, I can do an inference in a canary way. That means I can send some traffic 80% to this XGBoost, 20% to this sklearn, and I can see both the outputs, which one is performing good, and I can see these predictions of both of those models. So I can forward this sklearn canary to divide the traffic to the one model side only. If you see this XGBoost also same. You can change any other publicly pre-built model available in the Google. If you go to this repository, there are plenty of models already available. You can try it out. Otherwise, you can develop your own model and you can upload into your Hugging Face public repository. From there also you can load it. This is sklearn canary. So canary service, I am creating an inference to divide the traffic 80% into the sklearn, 20% into the other. So right now 80% means it is coming to my sklearn. Rest of the traffic will route to the my XGBoost. So this is what it's going to do when I run this deploy model. So when I going to do this deploy model, it will be going to deploy it. Copy and paste. It's creating KServe demo namespace. I can open one more terminal, kubectl get pods -n. What is the namespace? KServe demo. KServe demo. See, init container is running. What this init container will do? Init container will load my package. Init container will load my package from the remote repository here, and then my main container will run. We discussed in our Kubernetes classes what is sidecar container, main container, init container.
We have not used VLLM till now, right?
No,
Okay.
I'll update the same repository, sir. Same repository I'll update like a 01, 02 lab is there, 03 lab VLLM, and 04 is Kubre, Ray and Kubre. So single repository,
Okay.
we have 4 stacks.
Okay.
models got deployed, and we can even I have a test inference file also, but we can do manually now. So what we do, I also updated readme, I guess. Readme.
Is it the VS Code that you're using, Rajani? What
The
ID is this?
it is the IntelliJ, JetBrains
IntelliJ. Okay.
IntelliJ. Yeah.
All right.
My VS Code is not loading in my system. I don't know, some trouble is there. From starting of classes, we seeing it said anti-gravity also some, but this one is working so speed and good for me, and also interface is
Okay.
so nice. So I started using this.
Okay.
Uh, Install KServe. Then I did somewhere manual codes also. Manual run. Yep, this is the one. No, not this one, not this one, not this one, not this one, this one, not this one. Yeah, this is the one I was talking about. Yeah, you can, or we can open the terminals, three terminals, to see how this routing and canary things will be happening. Right now, I would like to open one more terminal here. Here, I'll open this terminal. So in the first terminal, I said that let's see these logs of my two pods are ready or not. Let me see the pods first. So XGBoost pod is there and my sklearn pod is there. Both pods are there. Why I'm keeping sklearn, sir? Because we are sending 80% of traffic to it. We need two replica. Means two pods. XGBoost is okay, fine. One enough because we are only sending the 20% of it. Okay. Now I wanted to see the logs of this one. Okay. Iris, sklearn iris. So copy and paste.
काय सगळे
Logs
पाहुणं
are
बिवणं
there.
किचल्यासारखं
Sir,
आणि
please mute.
असं सवय असते ना ते कधी
Yeah. So here you can see Ubicon is running right now. No logs are generating. Whenever we do prediction, the logs will generate. It's going to be log over there. Now I'm going to enable one more. So let me rename the session like sklearn. Okay. And I'm going to take one more, and this I'm going to rename it as XGBoost. Okay. So here, okay, I have to this one paste. See the XGBoost. Both logs are there, XGBoost and this one. Now, if I run, if I run any prediction, then the routing should happen to the sklearn, not to the XGBoost. Okay. Right now, I can do this in a third terminal. In third terminal, I will run this one, which is sending an input to do a prediction. So it will return. Okay, here you can see. Yeah, it's not happen. It's not working. Let me send then this loop, this loop, loop it, predict. If you see sklearn, XGBoost, request 1, request 2, request 3. Why logs are not okay? Run one more time. to connect service LTS. What happened? Running only. Loading low. Okay, let me open my other terminal then. Let me close all this. And let me run this command. Let's do a port forward. Now you have this one and you have this one, and you did port forward, both of them. And now run it. It got logged, you can see. And now let me run loop. This loop is, it's going to give it 10 requests back to back. And let me run now. So here no logs, but here lot of logs. It is going to the one sklearn only right now. Okay, so this is how it is happening a canary with my canary deployment. Okay, so you can run this manually also. I have given all the commands here. And one more thing is, there is a test inference. You can run test inference now to see this how inference things are going. So this one single script will do all this thing. All these manual commands I have updated in this script. It is just updating, beautifying the script. That's it. To reduce manually running and all. So you can easily learn and you can save some time. Now this prediction is sending that. So right now I'm sending this information. Then it is telling that 191. And XGBoost is telling that in this plots like 1.0 and 1.0. So there is a decision. Now my XGBoost is running on 8082 port number, and sklearn will be going to run on the 8080 port number. Okay. This is a predictions. XGBoost and sklearn doing. So this one is doing 0 0, and this one is doing 2 and 0, and this one is doing is 2 and 2.0. So it is just prediction, single model only, but in a different methods. Like we have this one, iris flower predictions. What it is? Those values 0.2. Those what these values are. So sepal length, sepal width, petal length, and these things. So this is a petal and sepal and petal and sepal. So it is going to predict this, and it will tell you that okay, iris setosa, okay, and iris virginica. So like this, it is going to predict which type of flower it is based on the inputs we are sending. So you can replace this model with your house prediction model, or your churn prediction model, or your any customer classification side. Okay, you can train your own model and put it over there. For now, I took a public model which is available only. That's why this is the input. So we can replace anything here. And the canary deployment is happening like this. Okay. This is we are doing on the KServe. KServe. kubectl get ns, the namespace is KServe demo, KServe demo, kubectl get pods or all -n and paste. When I say kubectl get all -n space, so I have pod, I have service, I have deployment, replica, and this is the HPA things are there. HPA things are there. Okay. kubectl get inference -n copy and paste inference services. Okay. This is command inference services. So you can see it's created inferences for me. This is the one. If I copy this and run, I have what services? Service I have. Kubesit get svc -n copy and paste. Cluster IPs. There is no these things. Okay, this URL is actually you're going to keep it like demo.example.com is there, right? So in the place of that, we will going to say that your company.com. So this is a servings that your KF service creating for you, HTTP endpoint. Okay, this internally in your network, you're going to update under your Route 53 networks, Route 53 records, load balancer records. Then otherwise you'll going to update this with your backend system, your JavaScript's backend systems there, right? So your backend services with them, you're going to update this one there. So the request will come there to here, and here it will do prediction. It will send the response back to you. So this is how it happens. The KServe is creating this one for you. My service is cluster IP only, sir. We are not doing any load balancer and all. We are not creating a separate HTTPS endpoint from my service, Kubernetes service. But we are creating this and it is routing through the STO. It's coming to the cluster IP, it's coming here. This endpoint is creating by the your KServe. So this is a stack that we are deploying our ML models in a Kubernetes cluster. This is how it look like. And one more thing is like, just give me a minute, sir. 1 minute. Yeah. Now this is one type. And the second type is we have Triton. Triton also same, but it is from the NVIDIA. If we see our manifest, same iris and models. What I am doing here, I am converting this same iris above into a ONNN package. So then I'm also taking one more sentiment which is BERT, distill BERT, which is text generation thing. So in the place of this, you can take Mistral and all, but if you take Mistral and all, you need a GPU server. So our server is a CPU server. I'm taking the BERT. BERT can work on in CPU for sentiment analysis from your text. So if I say something like this movie is good or you are a good person, then it will say positive, negative scoring. So that the BUT will be doing on a sentiment side. And this iris again is going to give you the prediction on this flower only. But if you see what I'm doing right now with this file, I'm taking, this is a Python script, I'm taking that pre-built public model and converting into the ONN. I'm converting into the ONN because I wanted to load ONN, different package, into the Triton within KServe. KServe can also do this one also. But we need to see the Triton. On the top of Triton, I'm loading this ONN1. So this, after I convert by using this .py, this file is going to convert, and these outputs are going to store in my S3 bucket. From that S3 bucket, it will load into the Triton server. From the S3 bucket, it will load into Triton server. Here also, from this file, I'm taking the BERT and then I'm converting in the ONN, and then I'm uploading into the AWS S3. So this is your small code, sir. It's not a big code, it's a small code in a Python. It can be done with any GPT. Okay. You just loading it, converting it, and uploading into your S3. So here test.py also have added, and here you can see manifest. So iris is now going to get from this S3 bucket, sir. This S3 bucket. This S3 bucket you can create manually. Otherwise, your script will create from the script. The script will create. So here my outputs are going to upload. Here my outputs are going to upload. In our Kubernetes class, we have discussed, right, sir, what is service account, secrets, config maps, right? And those things will come here. In order to communicate from your Kubernetes cluster to your AWS S3 bucket, you need a service account. You need a secret. Okay. So those things is going to done by your script. Here I have a script which is setup S3 and credential.sh. This raw commands also you can run in the terminal manually. AWS S3 API create bucket and the bucket name. This is a variable. I have given this variable in the starting. Okay, region, bucket, account ID. Okay, so here model repo is model repo and model this one, and the region it's going to be take from the AP South one. This is the one. It will run my AWS STS get caller identity so that it will print the AWS ID, my account ID, and bucket name is going to be a KServe Triton lab with my account ID, and the namespace is Triton demo. Triton demo. And then it's going to run my AWS commands to create the bucket, and inside the bucket, after this training happen, it will push the outputs there. Okay, so this is what happens, sir. So if I go to this readme.yml, I have updated very clear steps here. Whatever I ran, I updated each command manually. I have updated here to make you more readable easy. I have updated more easily here by just writing this readme in a nice way. It's not loading. Yeah. If you run this all, it will run all the shell scripts. But no, we'll run one after another. First, we will run upload S3 plus setup credentials. Let me run this. But I need to switch to the lab 2. I need to switch to the lab 2. Scripts. And then run this, sir. This command should be, you have to run. Yeah. And then run this one. setup S3. Now see, it's fetched my account and it is creating the bucket. If I go into my S3 bucket, refresh, bucket is created, but nothing is there inside. Nothing is there inside. Okay, now it's done. Second thing is, see, created S3 bucket and we will be going to upload ONN models into this, and it's creating the secret credentials for it to access your KServe to the S3. Okay, Triton with S3. Now we are deploying Triton models. Deploy Triton model.sh. Deploy Triton model.sh. So here I am running kubectl inference service all for KServe. So in order to clean up the space, I am running this to delete the old lab. Then after, I am running this YAML. This YAML is creating a namespace. That is a namespace, right? In that namespace, from this your S3 bucket, it will load your outputs into your Triton. But now, in order to deploy this, you need a service account. So this is a service account. It will be going to create kubectl get sa, but let's see ns. Ns is you have KServe and KServe demo, and okay, above does it created any namespace? Account on, no, it's deleted the namespace only, and later it has to create the namespace. Okay, sa, and then inference namespace. KServe demo only, I guess. kubectl get. I created two things. I need to maintain some good naming convention. These are running. I think it we not ran, so it is going to delete. Let me run this. Let me run this. Let me run this. Paste. No such. Triton scripts deploy Triton model.sh. Scripts lab config. 14. Dot lab config. Lab dir. Doesn't it create it? Lab config. Config file is there. Config file has to create. Array, I have to train the models first. Okay, I think I have updated in different manner. Let me run this. Test model, Triton, cleanup. No, I have wrongly updated steps. First, we need to run this. models things. But let me run this. ONN conversion complete. Now it is updating. Something step I have wrongly updated then in some YAML, some shell script. So now it is uploading, see, the convert models into there. And it has to create. Let me go here. Triton repo. Iris. ONN 1 model.onn. Okay. If I come here, creating service account. Okay, it is running in a sequence. I have updated step wrongly. I guess that shell scripting is not working properly. Setup credentials is ran, and after setup credentials ran, after run all the this is the one perfect script. Let's see the commands here. Step start, date. Okay, it's running this one, Triton feature.sh, test.inference, deploy Triton dot this one, setup dot this one. This one I have didn't ran, so it will prepare the models. This is I have skipped. The 001 I didn't ran. I directly ran this one 01. If you see, that's the problem. I skipped it. 02. See, Triton scripts. 01 I directly ran after changing the directory. See, from the 01 to 02, I only ran directly that one. That is the problem. Your scripts are working okay, fine. And because in the morning only I did this all refactors. Cool. Now it is downloading the image 1 GB, that is your Triton image, into your Kubernetes cluster. Once the Triton is okay, then kubectl get, just a minute. kubectl get ns. We have Triton demo. Get pods -n Triton demo. Crash loop backup issue. Why? Let's wait until it's complete 600 seconds. The image is triton.model.sh. Step is deploying models on Triton. 50 tokens. Deploy Triton models. Step 2 by 4. Deploy Triton. $270. So it will take at least the time, sir. Let's wait for it. So meanwhile, you can have a water. I'll be back in just one. There was a error, I guess. Timeout. kubectl on paste. Container is started, already present in the machine. Storage is started. I think main container not started. Crash loop back. Bad request. Container in pod Triton was waiting to start. Pod is getting initializing. Hmm. Pod is getting initializing. Both has to be initialized. Last time I added from my experience YML inference, just change runtime. Two inferences it will deploy. Okay. Model for can you obstruct the runtime? Is this there? What I updated in the last time? No, it won't cause any error. Deploy to demonstrate healthy. Then I can do directly. Okay. It ran which step? Deploying models on Triton 2 by 4. 2 by 4. 2 by 4 is, yeah, this is a file. Triton image is 1 GB. Does my namespace are created? The space is enough or not? kubectl get ns KServe demo. Enough only. 1 GB. Bah, I didn't enable SSH. All only. Security group. All only there. I think it's not under managed. So when I say nothing. So in real time, you will be not connecting like this. You will connect through the SSM manager. Sudo show why this command root only. Amazon Linux only. Sudo show what Still, Titan image is this much is taking. Let me run one after other. No resources found. Directly applying here. Script is not good. Okay, when I run this, deposit got set up. This is so small terminal. Let me run it here. Control C, Control C, kubectl get ns, kubectl get pods. Kubectl. Bug issue, and here it is telling that initializing the entry point 17 model KServe. Oh, signature does not match. That means from the model it has to load NVIDIA Triton Server PY3. It's a small one only, right? Why it is not loading? Cloud socket. Volume mounted available STOC record failure to sync. Timeout, wait for the storage. Oh, there's a problem, I guess. There is a problem. Container is not iris depth MNT info storage by download. Okay, Triton repo is correct. Uh, 63. There is an error specific operation response time and it's calling the list objects are not the request signature. Okay, it's not authenticating properly. That's the issue. So if I go to my console and bucket, let me see the path properly. We have path.
I think
Okay.
with the latest one, Rajani, I think they are not recommending the access keys and things like that. They,
No,
you
no.
know, from the client, you can do AWS login, and then you can use your authenticator, the generated digits.
Yes, so that is the problem. The signature AWS is not accepting right now. You're correct, sir. But it will be loaded. It will be loaded because SA account we have created, service account. It's okay. It will load. Somewhere did I missed anything that SA account I already created. Prepare, convert. It will run the that files. Okay. lab.config is created. Where region, this one and this one. That's fine. Maybe it's created essay, right? kubectl get just too small. kubectl get essay -n. This one, Triton demo. There, essay account is there. Secret. It's there already. If my secret is already created, then why my service account is not authenticating? There might be some issue here only. Okay, I have to delete this one, then we'll recreate again. Okay, not there. If I go here, not this one. It's again the CM problem, sir. Let's do this. If it is not authenticating, maybe generic one I have to do might be. Mm, what we can do, we can try like this. But here I have to configure access key and secret key. I'm just pausing screen, sir. Uh, then let's see now. Now my service account there, to my service account. KServe. After generic created, then it has to authenticate means I have to annotate again to that. But to annotate, yes, say. Copy and just ask a GPT that do I have to annotate anything, because credentials, all this already annotations there, but you want no annotations needed, no need, already S3 is there. No need of IRS right now. I'm not doing it. then kubectl get pods -n. If it is, again I have to describe kubectl describe. No, so okay, let me describe pod name plus namespace. It's getting backup kubectl logs pod name -c container init container. Control C, copy this because something is happening in error with the signature match. List object. So let me ask you. So list objects are operations. The signature is calculated does not match the signature provided. So signature match wrong AWS. Is it? No. My keys are correct only. Yeah, annotation. You should annotate the service account like this. If your bucket is no, it is in the same region only, right? Not this one. Which region? AP South only. Something. Let me annotate. Okay. Then get pods. Let's delete the pod kubectl delete. They get into the crash loopback, out of crash loopback to now in it you can see. That one is error. Skip and watch. God, it is also into error. Crash loopback issue. So there is a signature issue only. But we already annotated, right? Since my things are already there, if I run it, it's showing iris. Correct only. Delete pod. I think I have to update this step. But if I come here, Triton SA. This is a step. This script is having a problem. Service account I'm creating, then this one, that it is going to authenticate with my local things only. Script cd directory, bash source, pwd, this one lab config. It will take namespace, bucket, then it will delete, and it will give print this one. Then it is going to update which container iris. So MNT model iris, the model is going to, it is going to create this directly, this workload here. Okay, while it is directly going to create, inference service account name is this one, sentiment service account name is this one. It has to load. That is what not happening. If I run this, let me again pause it, sir. Let me update the credentials. So I have ran right now. It was created kubectl get ns. No, cool. It's already with 10:30. I'll do one thing. I'll just fix this one. So the signature or this authentication is why it's not happening. The only milestone part is like if it is loaded, we are running inference. That's it. So that's the thing. Let me look at it this weekend, and then you can practice it, sir. So otherwise, I'll try to record a video on the VLLM also on this weekends, and you can, whenever you have some time, just go and see, and we can save some time. So for the cleanup thing, you just run it, sir. Just don't keep your cluster like this, otherwise I will.
Rajani, I would prefer to do it in the class, Rajani. Don't record a video and upload it because I know if you have any questions, then
Hmm, hmm.
in the class probably we can ask it then and there.
Yeah. Okay, sir.
Thank you. But I mean, it's I would like to ask others as well if they prefer video, then probably you can go with that route. But my personal feeling is that it's better if you
No,
do
no.
it in class.
Things is like it will be more cut short. Like now we are running this lab for 2.5 hours, right? Like thing is, if any small concept is there, I'll try to finish up in it in a direct, straightforward, and detailed, so that when you go and see, the video will be very clear to you. And next day, I'm only telling you about the small labs. Next day, you can ask me anything regarding that if it is not okay. So because I'll get enough time to prepare a notes for it, and you can see it like a small concepts, not like big labs like this. Big labs we will do in a live class only. So big labs, if I say in a recordings and you just see, after 30 minutes you lose your interest automatically. I know that, sir. So recording is not taking more than 10 minutes. I'll record. If it is taking more than 15-20 minutes, okay, we'll do a live class only, sir. So let me delete it, sir. In the last, I have updated delete thing also. Even some interview questions also have added here. Interview question regarding the KF sir. Zero 05 cleanup. Cleanup 07. It will create lab, EC2s, model services. Yes. Let me check my bucket also there or not. Not there. See, bucket also got deleted. Fine. It will going to delete my cluster also, sir. I'll update with other two labs as well. So Ray and VLLM, the same repository, one repository for you having 4 stacks. Clear. I'll spend a lot of time on the README because I would like to update all the steps and each notes in the README only. Okay. It's now getting, see, the cloud formation stack is running to delete my cluster.
And also the scripts, basically.
Yes, yes,
Isn't it? It's
scripts.
not just the README.
Yeah. Scripts here in this folders only, script folder.
Yeah.
And it
Okay.
is very clear and neat, sir. There is no clumsy thing. Direct bash commands only.
Yeah.
Just I'm beautifying with echoes.
All right. That's great.
Cool. Okay, eventually it is going to create delete my cluster, and we'll meet in next class, sir.